Good evening, Doctor. My name is A Bester. I'm currently doing my bachelor's at Unisa, and I'm going to discuss my geometric road design project. For my project, an existing gravel road in the small town Victoria West needs to be upgraded to a 4-lane divided surfaced road. This presentation will discuss the description of an existing gravel road, the standards and guidelines that was used during this process, final design of the road, final design of an at-grade intersection, drainage requirements, and some additional info. During my site visit to the road in Victoria West, I found that there was no road signs, there was no road lights, the road was completely corrugated, there was no drainage systems. There is enough space for an upgrade for about 25 meters. I also did some traffic counts. The books I used for standards and guidelines that was used during the design processes was the Red Book's Guidelines for Human Settlement Planning and Design. As you can see, there's a typical figure of the elements of a cross section I used. It also came out of the Red Book. In the Red Book, Chapter 6 helped me with some stormwater management. Chapter 7 helped me with the design and layout planning, and also giving detailed coverage of geometric design for roads. The technical recommendation for highways, the THR, was also used. All the final design processes, it was concluded that my road will exist of a verge. The verge will be on both sides of the road, ensuring some proper drainage and guiding the water away from the road. The walkway is to ensure the public safety and the pedestrians walking nearby and living in the rural areas. The side curves is to help with the drainage systems that was designed for this road. An inner and outer lane will be used going both directions of the road. In the middle of the road, we have a median that is used as a divider between the two directional roads. Some yellow lines will also be used for the shoulders, to indicate the shoulders, and some appropriate white lines and road markings and signs will be used to ensure that all the rules of roads are implied. And this is the satellite image of the current road in Victoria West, going from the town to the airport. The red line indicates the upgraded road. The start of the upgraded road will be at stake value 0, and the end of the road will be at stake value 2,950. In my project, I designed the super elevation part of the road. The super elevation part of the road started at stake value 25 and ended at stake value 780. In my design, a new intersection was included, as well as a new bus stop. In my design, it was concluded that the roads will have new street lights spaced 40 meters apart. Final super elevation design, I had to check if the current super elevated curve is adequate. I used the guideline tables from the Guidelines for Human Settlement planning and design to help me. Table 7.11 was used for the maximum super elevation percentages. As you can see, this is a table out of the red book, just to show how I got my results. It was a simple reading from the red book, and I saw that the maximum super elevation percentages was between 2 to 4%. Table 7.12 was used for the minimum radiance of horizontal curves. Table 7.13 was for the minimum length of a super elevated runoff length, and then all the calculations was done. The calculations was used to determine the final road levels. During my design, I designed an at-grade intersection. My at-grade intersection had to have some medians, some indicating arrows, some pedestrian crossings to ensure the safety of the pedestrians. Also in the project there's a more detailed drawing of the pedestrian crossings, curved edge for the drainage. All necessary road markings had to be on the road for the intersection. All necessary road signs was also included. Just this area showing the verge and the island that was also included in the at-grade intersection. For the intersection design, I had to check if the current intersection was adequate. Using guideline tables from the Guidelines for Human Settlement Design, Planning and Design, known as Red Book, I used table 7.5 for the design speed. Just another table to show an example of how I got my results. It was also just a simple read out of the book. Table 7.6 was to determine the stopping side distance. Table 7.7 was to determine the decision side distance. Table 7.8 was the decision side distance on level roads. And figure 7.5 intersection side distance for cross maneuver. I'm going to show you also how I used this figure to determine my side distances. But just simple reading off from the figure. As my design speed was 60 kilometers per hour, I could easily read off all my distances, my intersection side distances. After doing the final drainage design, it was concluded that there would be two types of sections for the drainage systems. The first drainage system would be a curbed side drain, where the water would flow in both directions to the edge of the road into the curbed sections, where the water would be guided to the catch pit areas and then transported in the stormwater lanes, pipe lanes, and then into a dam. Then the second drain was where in the super elevated, one side of the road would go towards the curb side and one side would go into the median. Then in the median there would be a side drain that would also guide the water towards the dam in the pipes. Extras. All the drawings was done and generated by myself using CAD programs, and I'd also declare that all of this is my own work. Thank you very much.